Okay, it is this. Okay, so I was saying I was saying that gx is ax squared plus bx plus c. Okay, so we are supposed to find yeah, you guys should be able to see me now. I've removed the intro page. So yep, I'm here at the bottom left corner now. So gx is ax squared plus bx plus c, and we are supposed to find d18. So we have this. Okay, gx, I'm replacing by a quadratic expression. And since this is going to be solved as a system of linear equation question, let's try to bring this up to see this as ax squared plus bx plus c. This is equal to 40320 divided by dx. And when x is equal to 5, d5 is 384. So using the first piece of information here, we know that when x is equal to 5, we have a 25a plus 5b plus c. This is equal to 40320 divided by d5, which is equal to 40320 divided by d5. This is given to us as 384. So our first equation will be 5 squared, which is 25a plus 5b plus c. If I were to press this into the calculator, 105. Equation number 1. We'll do the same thing for equation number 2 when x is equal to 8. So when x is equal to 8, we have a 8 squared, that is 64a plus 8 times of b plus c is 40320 divided by d8. d8 is 224. So this gives us our second equation. That will be 64a plus 8b plus c. This is equal to 180. Equation number 2, and the last equation is when x is equal to 10. So we have a 10 squared, 100. 100a plus 10b plus c. This is 40320 divided by d10, 168. So this gives me my last equation, 100a plus 10b plus c. This is equal to 240. This is equation number 3. We just need to press all these equations into our graphing calculator. We should be able to get A as 1, B I have gotten it as 12, and C I've gotten it to be 20, which means that dx, which is going to be this, so it will be 40320 divided by A, which is 1, so this square plus B, which is 12x plus C. This is 20. And the question asks us for the number of units when the price is 18. So the question is asking us for D18. This will be 40320 divided by 18 square plus 12 times of 18 plus 20. We have gotten our answer. So the number of units that the people are willing to purchase at a price of $18 will be 72. Question number 1, system of linear equation. It is a very simple question. Okay, not exactly super simple, but it is okay. Okay as a question to start with. Let's move on to question number 2. By the way, last week on Friday when I was streaming, somebody was suggesting that like streaming on Twitch. Do you guys really think that it is a good idea to be streaming on Twitch? It's like math, but Twitch is like for games. I mean, unless people see math as a game, or else isn't it a little bit weird to be streaming on Twitch? I mean, once in a while I do see some education stuff being streamed on Twitch, but I don't know. Wouldn't it be a bit weird? I mean, what will the Discord community think, right? Next, let's take a look at question number 2. Question number 2, it is a summation question and it is an okayish question also. So for question number 2, part 1. Question number 2, part 1. I mean, here is definitely okay. I'm just wondering, about simultaneously streaming here. I mean, YouTube is, I'm already streaming on YouTube, but I'm just thinking, how about simultaneously streaming on Twitch? I mean, no matter what, Twitch is the place to be, when you do a live stream. So I was just wondering, but I don't know. It's really a very much of a gaming platform. So part 1, we are supposed to find the summation from n is equal to 1 to n of Pn. So this is going to be summation from n is equal to 1 to n. According to the question, Pn is given to us as ln of 1 plus x to the power of n divided by 1 plus x to the power of n plus 1. And we need to decide our strategy to evaluate this summation. We can either evaluate using results that we have pre-memorized or results that are given to us by the question which we don't have any. Or of course, we can try to make use of pattern recognition. If it is pattern recognition, then I guess what we can try to do is to make use of the method of difference. So in order for us to trigger the method of difference, we need something minus something. And we have ln something divided by something, which means that I can also rewrite this as summation from n is equal to 1 all the way until n of ln of 1 plus x to the power of n minus ln of 1 plus x to the power of n plus 1. And can I remind you guys to make sure that you remember to put in this bracket? I know a lot of teachers, they really feel very anchored by solutions where students don't put this bracket. So please remember, okay, I don't think you're going to lose marks just because you didn't put a bracket. But I always see the angle from the scripts that I read from my students' exam, how hard the teacher circled that part, saying that, signaling that, hey, please add in the bracket. You're not just summing the first term, you're summing this entire thing. So we're going to try the method of difference. But one thing that I'm not sure, but in case some of you, in case you are someone who may get distracted by x, let's remember x is not going to be affected by n. Okay, so this x, in a way, within this summation notation, we are seeing it as if it is a constant. So n is the one that is changing. I'm going to let n be equal to 1. So this is going to be ln of 1 plus x to the power of 1 minus ln 1 plus x to the power of 1 plus 1. This. And when n is equal to 2, so you'll be ln 1 plus x to the power of 2 minus ln of 1 plus x to the power of 2 plus 1, 3. When we are trying to when we are trying to list out the terms using the method of difference presentation, we are trying to recognize a pattern. So it is not just subtraction. It is trying, if it is subtraction, I will definitely subtract this and this, it will become 0. But we are trying to recognize a pattern. So I must make sure that I write down one more row so that I can see some kind of pattern. And in this case, it is a pattern of cancellation. So we are seeing this and this can be cancelled according to the same kind of pattern. We're going to test this pattern using the last 2 rows. Because for the first 2 rows, I'm starting to see the first pattern of cancellation. So for the last 2 rows, when n is equal to n minus 1, we have a ln of 1 plus x to the power of n minus 1 minus ln 1 plus x to the power of n minus 1 plus 1 n. And the last row will be when n is equal to capitalize N. So it is 1 plus x to the power of n minus ln of 1 plus x to the power of n plus 1. And we do notice the same pattern of cancellation, which hint to us that in between they will all be cancelled in the same way. So this will leave us with a ln of 1 plus x minus ln of 1 plus x to the power of n plus 1. It is not necessary, but I mean, I guess we can still combine this together to become 1 plus x divided by 1 plus x to the power of n plus 1. Okay, this is part 1. And part 2. Part 2, we want to find the sum to infinity of the series in terms of x. And I'm a little bit surprised by the marks allocation here, 2 marks, because usually for a question that is like this, they usually gives just 1 mark. You know, I cannot really remember, have we done a sum to infinity question before? Because if you have done it before, I should have explained that usually when this kind of question carries 2 marks, it is because they want a reasoning, and then subsequently they want the sum to infinity to be given. So it is supposed to be answered in 2 parts. But this question is asking for just sum to infinity, and then they give 2 marks. So I think the safer thing to do is probably to give a reason too. So I'll say something that is like as n tends to infinity. As n tends to infinity, I'm going to focus on the term that carries this n, which is this x to the power of n plus 1. According to the question, x is between minus 1 to 1, which means that when n tends to infinity, x to the power of n plus 1, this is going to tend to 0. And since this is, and let me write down, this is because x is going to be between minus 1 and 1. Therefore, we know that the sum to infinity from n is equal to 1 to infinity of Pn, it will be this ln of 1 plus x divided by 1 plus, when n tends to infinity, this becomes 0. So my answer is ln of 1 plus x. I personally thought this is even easier than question number 1. Yep, clear, matter of difference. Okay, let's take a look at question number 3. We have started off with 2 slightly easier questions. 3 is a tiny little bit more difficult, but it is still okay. And I think it is a very fairly set paper. I like to do this kind of paper that are very fairly set for the entire cohort. So I mean, sometimes paper that are too difficult, it just makes you feel that the effort that you have put in to study has gone to waste. But of course, it is not going to. Schools will have a good strategy, and the reason why they are setting a paper that turns out to be a bit more difficult. But sometimes we will still have that kind of feeling that, oh goodness, our morale will be brought down because the prelim is like so difficult. Question number 3, we are looking at a triangle ABC, and the angle ABC is pi over 2 minus x. Pi over 2 is 90 degrees, and the question says that x is sufficiently small. So I'm going to do a quick sketch, and I just want to explain to you why my sketch looks this way. Is because I am intentionally making angle ABC look somewhat like a 90 degrees. Okay, so pi over 2 minus x, where x is small, will be here. So I mean, not necessary that you draw until it looks terribly like a pi over 2 or 90 degrees, but I guess it is easier for us to discuss if we can at least have a better understanding of this pi over 2 minus x. And the question says that AB is 1 and AC here is 2. We are supposed to show that BC, this one, follows this polynomial, this quadratic polynomial. So we need an equation in terms of BC. For a question that is of this nature, many times we will be using cosine rule and sine rule. So for those of you who are having your prelims before, okay, no, not just those of you who are having before, those of you who are having your prelims, please make sure that you memorize your cosine rule and sine rule, okay? Because once in a while I'll hear students who will lament after the test that they could have done the question, it's just that they have forgotten sine rule, they have forgotten cosine rule, and the worst was some students thought that sine rule and cosine rule, they are in your formula sheet, but they are really not. So I'm going to make use of the cosine rule using AC. So AC square here, cosine rule, this is going to be AB square plus BC square minus 2 times of AB BC. Then cosine of this angle, pi over 2 minus x. AC, this is 2, so we have a 2 square. AB is 1. Then BC is what I'm going to try and make the subject. Minus 2 times of AB, which is 1. Then BC. I am going to convert this to sine of x. Well, let's not forget about our trigonometric transformation. This is complementary angle. So sine of pi over 2 minus x. Complementary angle, this is equal to cosine x from secondary school. Cosine pi over 2 minus x. This is equal to sine x. And tangent of pi over 2 minus x. This is equal to cotangent x. Well, please make sure that you memorize this. I don't even think it is that common in Maclaurin's, but it is probably going to be pretty useful when it comes to complex numbers. Okay, anyway, let's just make sure that we memorize this, okay? It can appear anywhere in H2 math. When it is not even in H2 math that you learn this, in case some of you have forgotten, this was from your secondary school. So I've applied I've applied this. Okay, that's why we can change the cosine to sine. So this is going to be, I'm going to make BC the subject, okay? So this that I'm looking at here, I'm going to see this from the perspective that this is a quadratic equation in terms of BC. So that will make it BC square minus 2 sine x of BC. Then this brings over minus 3. This is equal to 0. Okay, so I have a quadratic equation in terms of BC, and I'm going to make BC the subject. So BC, using the quadratic formula, it will be minus B. So it will be minus 2 sine x plus or minus square root of B square, which is minus 2 sine x square minus 4AC. Is divided by 2a. Okay, quadratic formula, looking at this from the perspective of it being a quadratic equation in terms of BC. So we have a 2 sine x plus or minus, this is 4, and here is also a 4. I'm going to factorize out a 4 because I know I can square root it. So we have a sine square x plus 3. This divided by 2. So 2 divided by 2, this is going to be sine x plus or minus. Square root of 4 is 2. 2 divided by 2, again, it will become 1. So we have a square root of sine square x plus 3. We need to reject one of them. Any suggestion? How do you think we can reject the plus, minus, and selecting just one of them? For BC, it is the length that we are talking about. So we know BC got to be a positive number. So when I was looking at this, I was just looking at this from the perspective that sine x by itself, it is going to be always between minus 1 and 1, correct? And as for this, how about looking at this from square root of 3? If you were to press your calculator for square root of 3, square root of 3 is like 1.7321, blah, blah, blah. So square root of 3 itself is already bigger than 1. So if I were to choose negative, and if this is going to be between minus 1 and 1, if I were to choose negative, this entire expression is going to be negative. So I'm going to choose the positive. Okay, so that the expression will remain as positive since BC is a positive number. So I'm going to write it as sine x plus square root of sine square x plus 3. Okay, this is because I want to maintain BC as a positive number. In case some of you missed what I've just said, I'm saying that sine x is between -1 and 1. And if you were to look at this, if you were to ignore sine square x, just square root of 3 itself is already bigger than 1. Okay, and sine square is definitely going to be a bigger or equal to 0 term, which means that this term, with the square root, this term is definitely bigger than sine x. That is why we need a plus. If we go for a negative, this whole expression will become less than 0. And then I'm going to apply the fact that x is small. So if x is small such that x to the power of 3 is negligible, that means sine x, if I were to make use of the formula in the formula sheet MF26, sine x will become x. And then this will become x squared plus 3 to the power of 1 over 2. I'm going to expand this further by making use of the binomial expansion on the MF26 also. So this, it will be x plus 3. I'm going to factorize out. Then I will have this as 1 plus x squared over 3. Then this to the power of half. And if I were to expand this further, it will be this. Then it will be 1 plus half of x squared over 3. The next term will be x squared over 3 squared, which gives us x to the power of 4. But according to the question, we will go all the way up to x to the power of 3. It's already going to be neglected. So I'm not going to go for x to the power of 4. So I'll approximate it to this. So my final answer is going to be according to this, right? So my final answer is going to be this multiplied by this. So square root of 3. This by itself, so plus x. And then square root of 3 multiplied by this and this, it will be 1 over 2 square root of 3 x squared. And let's make sure that we answer the question. P, Q, R are terms to be determined. So P is square root of 3, Q is 1, and R is this 1 over 2 square root of 3. Okay. Okay, and the questions start to get a little bit more difficult. A little bit more difficult than question number 1 and 2, and they started scaling it up a little bit, to 3, and then a little bit more to question number 4. So let's take a look at question number 4 together. Let's see question number 4. Okay, it is a conics question since they mentioned hyperbola, and we are also going to be looking at it as a graphical transformation question. Let's see. Okay. Part 1. 1 mark. We are supposed to find the largest possible set of D. I guess in order for you to write down a set of solution that is worth just 1 mark, you got to try to immediately see this as the hyperbola that they are trying to talk about, and from the features of the hyperbola, you quote what is the range of values for D. Okay, so if you are able to see, I don't think I will need to explain to you much. But just in case you're not able to see, there's another strategy that we can try to use. A little bit longer, definitely more than what this 1 mark is supposed to be. I mean, more than a set of solution that is represented by this 1 mark. But I guess it works also because for the domain to be the largest possible, I just need to make sure that whatever that is inside the square root is going to be a bigger or equal to 0 number. Then it is possible for us to get a real number, correct? So for part 1, let's try to find what is the possible range of x if I were to be letting whatever that is inside the square root, this over 36 minus 1, to be bigger or equal to 0. So this will be x plus 5 square over 36. This is bigger or equal to, this is bigger or equal to 1. So x plus 5 squared, this is going to be bigger or equal to 36. And I think it is very dangerous if the first thing that you thought of is to square root both sides. Well, this never worked, right? For those of you who have already, who are already in your J2, you definitely have seen, if you are thinking about it now to try to square root both sides, you have definitely done question that is like this and gotten it wrong before. So let's make sure that we don't make this mistake again. I'm not going to just square root both sides. Okay, I'm going to bring everything onto one side. So 36, I'll bring it to the left hand side. Let's write it as 6 squared. This is bigger or equal to 0. Then I'll apply a squared minus b squared to factorize this. So plus 5 minus 6. This will be minus 1. Then x plus 5 plus 6. So plus 11. This is bigger or equal to 0. Then we can draw the number line. It will be minus 11 and 1. If you were to sub in numbers, it is going to be this. So we have this and we have this, which means that x is supposed to be less than or equal to minus 11, or x is supposed to be bigger or equal to 1. We are supposed to find the largest set of values for d. So d here, the largest set of values for d, it will be from minus infinity to minus 11 inclusive of 11, or from 1 inclusive of 1 all the way until infinity. Way more than what 1 mark should, way more than the kind of solution that we should put down for 1 mark. So I'm just writing down this in case you cannot like immediately visualize the hyperbola. Okay, next part 2. Part 2, we know that it is a hyperbola, and in order for us to code the equation of the hyperbola, again, we need to be able to imagine the equation of the hyperbola from here. But let's say we couldn't imagine that, that's fine. Let's just put in a little bit of effort to come up with the equation of the hyperbola by letting, for example, y be equal to this. So square root of x plus 5 squared divided by 36 minus 1. Squaring both sides, y squared is equal to x plus 5 squared over 36 minus 1. I'm going to bring y over to this side and the 1 over to this side. So we will have a x plus 5 squared over 36 plus y squared. This is equal to 1. So, minus y squared. So now we have a hyperbola, and from the equation of this hyperbola, we should be able to deduce the equation of the asymptotes. So the asymptotes will be two asymptotes. They will be y is equal to, this is, maybe let me just write it as 6 squared. So I'm assuming that you guys have already memorized the equation of the asymptote, or at least know how to derive the equation of the asymptotes from the equation of the hyperbola. So the two asymptotes will be y is equal to minus 1 over 6 of x plus 5. The other one will be positive 1 over 6 of x plus 5. Okay, so two equations for the asymptotes. I'm quoting down these two based on the fact that I have gotten the equation of the hyperbola. Next, part 3. Part 3, we are supposed to sketch the graph. We can definitely try to press this into the calculator. Not super necessary, but let me just show you. Do I have... Okay, yep. I have a screenshot of what I've gotten on by pressing this into the calculator. So this is what I have. And we know that our calculator has a little bit of problem, which is the calculator cannot draw curves that are too vertical. So let's make sure that for parts that are like this, we want to know that it actually probably behave a bit more like a vertical line down, but it is a curve. We have a bit more like a vertical like down to the x-axis. And when we are sketching the graph, we will, like what I have mentioned before during our first few streams, let's make sure that we sketch in the asymptotes first before we sketch in the rest of the graphs. So I'm going to sketch in the two asymptotes, and they are going to be this. This will have a positive gradient, so this is the 1 over 6 x plus 5. The other one is going to be this. It is basically a reflection of this. So we have the other equation as this. This is y is equal to minus 1 over 6 of x plus 5. So actually we don't even need this to be so long, since we are going to be just looking at the part that is above. So this is y is equal to minus 1 over 6 of x plus 5. This point here and this point here, it will be based on the center. The center of a hyperbola here is going to be minus 5, 0. So here is minus 5, 0. And 6 talk about the horizontal distance of each of these 2 points from the center. So this plus 6 will give me a 1. This minus 6, it is going to give me a minus 11. Which is what we have gotten in the first part, right? First part, let me just rewrite the answer again. First part, we saw that for D, it is from minus infinity to minus 11 inclusive, or from 1 all the way until infinity. So we are saying this here because my hyperbola is going to be starting from here with a solid dot, then tending towards the asymptote this way. The same for here, then tending towards the asymptote. Goodness, this is a very, very ugly graph. Okay, I have no choice. I need to draw it again. Okay, so okay, a little bit better. Okay, I have this. Let me make this more prominent. We have always talked about the power of endpoints being properly indicated. Solid dot, hollow dot. So we have this as the graph of y is equal to fx. And it's synchronized to our calculator, and it's synchronized to part 1, where the largest possible set of D is from minus infinity all the way until minus 11, and then from 1 all the way until infinity. That is why for part 1, if you are already able to visualize the equation of the hyperbola, then you probably can just make use of the visualization to code this without having to try to do it algebraically. Next, we are supposed to sketch curve for 1 over fx and f prime x. In fact, because we have already sketched this into our GC, so which means that on our GC, y1 is already this square root of x plus 5 square over 36 minus 1. If you don't know, we can actually do a 1 over y1, which will give us this 1 over fx, because this is fx, right? This is fx, and this will be 1 over fx. And where is y1? y1 is when you press for alpha trace. When you press alpha trace, it will be possible for you to select y1, y2, y3, and so on. You can give this a try, and then you will immediately get the shape of 1 over fx. But I don't think that is going to be sufficient, because you need to fill in the details, and the details are not going to be given to you by the question. So anyway, for 1 over fx, you can press your calculator as this. Let's say you plan to press for f prime x. It is actually also possible. You press math, then select differentiation. You are going to get this, and you will insert x into here, and then here you will insert y1. Then you just let x be equal to x. This will actually sketch for you the graph of f prime x, which means that this entire question, you can actually verify the shape of your graph, less the details. Without the details, you're not going to get the 4 marks. But at least the shape of the graph can be determined from your calculator. Let's try to sketch the 2 graphs. So for part 4, let me sketch first the graph of y is equal to 1 over fx. I'm going to use the same strategy as what I've talked about on the Achevas TV under graphing techniques. There is this 1 over fx. So the first thing that I'm going to do is I'm going to work on all the asymptotes. There's 2 oblique asymptote, and for oblique asymptote, I'm going to be working on points that are here and points that are here. So for example, a point that is here, I'm going to assign to it an arbitrary coordinate. So if assuming that it is very, very much to the left, I'm talking about like, for example, minus 1000, and it's very high up. So for example, like 1000. So this is going to be a point that is on the graph of y is equal to fx. And if transforming this point to a point that is on 1 over fx, this will become minus 1000, and 1 over 1000 will be 0.001, which means that on my graph, let's say this is the x-axis, let's say I have the y-axis at here. So my graph, this point is going to be translated to a point that is somewhere here, minus 1000 and 0.001. Similarly, I'm going to go for a point that is here, which is, for example, 1000 and 1000. When it is transformed onto this graph, this point is going to become 1000 and 0.001. So it is going to be somewhere here, for example, very, very close to the x-axis. As for these 2 points, they will become vertical asymptotes. So the first thing I'll do is I'll analyze all the asymptotes. This is my analysis. The second thing that I'll do is I'll analyze all the xy intercept, and there are 2 x-intercept. X is equal to minus 11 will become a vertical asymptote. So x is equal to minus 11. Similarly, x is equal to 1 will become a vertical asymptote too. So we have this, x is equal to 1. And when it is a point that is pretty near, oops, I shouldn't draw it here. When it is a point that is pretty near to the asymptote, it is a point that is just before minus 11, I'm going to give it an arbitrary coordinate also, for example, minus 11.1. The y coordinate, I'm going to go for 0.001, which means that when it is transformed, it will be minus 11.1 and a 1000. So plotting this point, minus 11.1 and a 1000, I know it is here. Joining these 2 points together, I have something that is like this. Similarly, this is going to become a 1.1 and a 1000. So you'll be somewhere here, joining to this. Okay, this is my graph of y is equal to 1 over fx. Okay. Then we will sketch the graph of y is equal to f prime x. So the graph of y is equal to f prime x. Again, I'm going to try to make use of the strategy that I talk about on the Achevas TV. But for f prime x, I think it is a little bit confusing because it is not together with graphings. But f prime x, I discuss it in the theory outline under differentiation. So I have 5 steps there. The first step is to try to ignore the x-axis because I don't want x-intercept to confuse me. And the second thing is I'm going to work on the asymptotes. There are 2 asymptotes, and I'm going to be working on the gradient because the y-coordinate that is on this graph represents the value of the gradient that I see here. So the second thing which I'm working on, the asymptotes, there are 2 asymptotes in the original graph of y is equal to fx. And for the 2 asymptotes, the gradient are plus and minus 1 over 6. So when it comes to here, it is plus 1 over 6. So we will have a horizontal asymptote, because the graph tends towards the oblique asymptote where the gradient is 1 over 6. So we have y is equal to 1 over 6. And similarly here, the graph tends toward minus 1 over 6. So the gradient will tend to minus 1 over 6. So we have another graph here. So we have another asymptote here. This is the asymptote y is equal to minus 1 over 6. And then, okay, that's it for the asymptotes. Next, I'm going to work on points that are where f prime x is equal to 0. I don't see any of them. And I'm going to, then the 4th step is to try to analyze the gradient as an overview. So to the left hand side of minus 11, I can see that the gradients are all going to be negative, which means that to the left hand side of minus 11, my graph are going to be less than 0, because the y coordinate which represents the gradient should be all negative, since the gradients are negative. And to the right hand side of 1, the gradients are all positive, which means that the y coordinate are supposed to be positive. So my graph must reside at the top part of the graph, of the x-axis, so that the y coordinate which represents the gradient can all be positive. What that is a little bit interesting about this question are these 2 points here. These 2 points, from our knowledge of hyperbola, we know these 2 points are going to be, if I were to be drawing the full hyperbola, these 2 points are turning points that are like this, which means that the tangents are actually vertical. When the tangents are vertical, this tells us that the gradient is undefined. So at -11, the gradient f prime x is undefined. So we should have a vertical asymptote. This is when x is at -11. Similarly for this, we have a vertical asymptote. So this is when x is equal to 1. And the fifth step is just going to go from the left to the right, analyzing the gradient. So the gradient is slightly less than -1/6. So all the way to the left, it is going to be a value that is slightly less than -1/6. Then the gradient will become more and more negative, all the way until -infinity. So the y coordinate will become more and more negative, all the way until -infinity. Similarly for this, it is going to be like super positive gradient, then slowly goes to 1/6. So it will start off with a super positive y when it is a little bit more than 1, when x is a little bit more than 1. So it will be here, going all the way until when it reaches 1/6. Not reaches, until when it tends close to 1/6, because it will never reach the oblique asymptote, so the gradient will never become 1/6. Okay, this is the graph of y is equal to f prime x. You try to sketch the graph of the gradient, but the calculator gives an error. Okay, I'm not very sure why, because I have to say I didn't actually go and sketch this, but I know in general this will work. I am not sure whether it is because of the region that is here, but it shouldn't be. Okay, I can't really tell why the calculator will give an error. Okay, so this I don't really have an answer unless I sketch it myself now. But in general, this y3 thing, right, you should work. In general, it should work. Yeah. As for the vertical asymptote, let me explain again, okay? Because if you, in order for you to get these vertical asymptotes, you need to already know that this is the graph of a hyperbola. Like what I was saying here, let me draw it here, okay? So I know this is part of the hyperbola. In fact, it is the top half of the hyperbola, which means that for this hyperbola, right, if I were to be drawing here, I will be looking at something that is like this. Okay, and like this. Okay, which means that at points that is like here, -11 and 0, the tangent is going to be vertical. So what is the gradient of this tangent? The gradient of this tangent is undefined because it is a vertical line. So if the gradient is undefined, that tells me that f prime x should be undefined. Okay, it goes for here, it also goes for this. It is a vertical line, so the gradient is undefined. Okay, the same for here. That's why here, at this point 1, I'm also going to be getting a vertical asymptote. Okay. I'm not sure why it has given a data type error, because this, right, x is equal to x will definitely work. I've tried it many times. So I don't think the reason is because of the x is equal to x. If there were to be an error, I think it could be because of the region where the curve is undefined. Then maybe the calculator tried to calculate the gradient for regions that are like this, and they realize that it has none. I'm not very sure. Okay, but in case you guys want to try this, okay, I'm so sorry. Okay, I actually didn't press this myself because I think doing this is like very fast. It's like doing the manual sketching. But in case you guys want to test out, whether how this will work, you can test out by, for example, letting this be equal to x squared. Then you try to let y2 be equal to this dx then after that y1, then x is equal to x. If you were to press this into your y2, you should get a straight line, right? Because if this is fx, I know f prime x is going to be 2x. So you'll be getting a line that is like 2x. So you'll probably get on your calculator something that is like this. This is the y-square graph. Then the other graph, y2, will probably look something that is like this. Oh no, I realize my head is covering it. Let me just shift away. Okay, you see. Okay, so it is not the x is equal to x, okay? X is equal to x is fine, it's really fine. Okay, anyway, I think this is a good question. Where especially the way that Hwa Chong has planned this is to make sure that students display their true understanding of f prime x, by doing an analysis on the spot. Where I think features that are like this on fx is pretty rare. That is why deducing a vertical asymptote is also not the most common thing that happens. Okay, I'm going to move on, okay, guys. Let's look at question number 5. Hang on, let me erase this. I always have some problem doing the erasing. You know how I wish I don't need to erase at all. You know, then I can leave the things there, but I don't know. I think my computer is not powerful enough to generate all these graphics. So whenever I do erasing, whenever I try to shift the whiteboard, then my computer will just hang for a short while, and that is very scary. I know for a lot of people who are on Twitch, they are definitely not using I'm using a laptop. So I think a lot of people on Twitch, they are definitely using a PC desktop where they up their graphics card and then their processor also. So anyway, let's take a look at question number 5. A complete eraser. Sorry, Claire, what is a complete eraser? They have a complete eraser. A complete eraser. Oh, as in like to erase everything, is it? You know, that that is what you mean by a complete eraser. Question number 5 is a vector question, which we are going to be dealing with all this kind of non-column vector A, B, and we have C also. Let's try to sketch a diagram. Okay, let's try to sketch a diagram to represent whatever that is asked by the question. Oh, I mean, I do have a complete eraser also. One click, they will erase everything. But I don't want to erase everything because it's going to remove all these questions that I've already pre-planted onto my whiteboard. Okay, anyway, let me try to sketch what the question is trying to say, okay? So we have point A, we have point B, and we have point C that lies on OB produced. So let me call this point here C, and maybe let me call this, maybe let's go for lambda is bigger than 1. So okay, let me go for this. Maybe this point here, I'm going to call it point B. Okay, we have point A with position vector of A and B position vector of B, and point C lies on OB produced, such that OC is lambda of OB. Point D is such that OCDA is a parallelogram. So we have something that is like this. So let's say this is D. So we have a parallelogram OCDA. M is a point that lies on AD, such that AM is to MD is 1 is to 2. So let's say M is a point here. The ratio is 1 is to 2. And the point N lies on OC, such that ON is to NC is 4 is to 3. So let's say N is, for example, here. Okay, let's say N is here. So the proportion here is 4 proportion, and then the proportion here is going to be 3 in terms of proportion. Let me try to see whether I can shift it such that I can avoid my head. Okay. Okay, got it. Okay, so we have this. And in part 1, I want to find the position vector of M and the position vector of N. So to find M, I think what I'm going to do is I'm going to quote AD first. Okay, because we have a parallelogram here, so AD should be the same vector as OC. And according to the question, OC is lambda of B. So lambda B. And I am going to quote AM, this vector here, AM. And AM is going to be 1 out of 3 of AD. So 1 over 3 AD. And the reason why I'm doing this is so that I can quote AM. Because from the diagram that I've just drawn, AM is going to be OA plus AM. So it is going to be A plus 1 over 3 of AD, which is lambda B. I should just write. This is 1 over 3 of lambda B. And ON. ON is this, which will be 4 over 7 of C. 4 over 7 of OC, which is 4 over 7 of lambda B. Okay, 1 mark each. Part 2. Part 2, we want to show that the area of the triangle OMD is this. So I'm going to make use of half of modulus of the vector of two sides of the, the vector of the two sides that represent the sides. The vector that represents the two sides of the triangle. So I guess I am going to go for the area, right? I'm going to go for a half of modulus of OM cross OD. We have OM is here. We don't have OD yet. So for OD, it is OA plus vector AD. So this is A plus AD. AD is lambda B. Okay, OD is this. So the area that we are talking about, this is going to be half of modulus of OM cross OD, which is half of modulus of OM, that will be A plus 1 over 3 lambda B, cross OD, which is A plus lambda B. So this is half of modulus of A cross A, then this plus lambda of A cross B, this plus 1 over 3 lambda of B cross A, and this will be plus 1 over 3 lambda square of B cross B. And we know that A cross A is going to be equal to 0, so this is a 0 vector. B cross B is also going to be a 0 vector, plus lambda of A cross B. B cross A is minus A cross B, so I'm going to rewrite this as minus 1 over 3 lambda of A cross B. So we have a 1 over 2 modulus of lambda minus 1 over 3 lambda, 2 over 3 lambda of A cross B, which is equal to 1 over 2 2 over 3 is a positive constant. I can just take it out without being affected by the modulus. Then we have a modulus of lambda, modulus of A cross B. But because the question tells me that lambda is also a positive number, that is why we can just simply write this as 1 over 3, 1 half times 2 over 3, 1 over 3 of just lambda of modulus of A cross B. And we are supposed to determine K. So from here, K is equal to 1 over 3. Next, part 3. P is a unit vector. Like what I've mentioned before in the past few weeks, right? Unit vector, okay, many times we tend to complicate unit vectors because there seem to be a lot of formulas and a lot of stuff about unit vector. But when the question says that something is a unit vector, actually there's just one key idea, okay, which is the magnitude is equal to 1. Whatever formula and blah blah blah, you know, they are extension to the idea of looking at a vector where the magnitude is 1. So they are not exactly, you know, about unit vector. So there's just one single thing, okay, magnitude is 1. So I want to give the geometrical interpretation of modulus of P dot A, where P is a unit vector that is in the direction of OD. The best way to answer this question is that you have memorized formulas that are like this. So I'm suggesting to my tuition class, and you guys should try the same thing also, is because now you are preparing for your prelims, you will see a lot of this kind of geometrical interpretation, geometrical meaning kind of question. My suggestion is to keep a list of you know, all this kind of interpretation so that you can memorize for your exam. I think it is faster. Okay, because if you don't memorize, it is also possible. Then you got to try to make some deduction. Let me deduce for you to see, okay? So, I mean, the best is to just immediately answer, okay? Modulus of P dot A is the length of projection of vector A onto the vector OD, or length of projection of OA onto OD. Okay, and this is because I've already memorized if P is a unit vector. But if I were to do a little bit of derivation, it is actually also possible. Let me derive for you guys to see, okay? It's not worth it for a 1 mark question, but let's just give it a try. So let's say I'm looking at OA. And we're also looking at OD, right? So let's say D is here, okay, this point. And so this vector here is vector A. And we have P as a unit vector. So let's say it is this short little vector here. So let's say this is vector P. So for this vector P, I know the magnitude is just going to be 1. And if I were to call this angle that is between A and P as theta, then we can try to quote the dot product by writing down P dot A, correct? In terms of theta, it will be modulus of P, modulus of A, cosine theta. So P dot A is going to be, what is the modulus of P? 1. So on the right hand side, we'll just be left with a modulus of A cosine theta. And what is modulus of A cosine theta? Modulus of A cosine theta, if we were to make use of the Tokaso, or some of you who have been watching the videos, I talk about the magic triangle. So this is like modulus of A cosine theta. Okay, because this distance here, what is this? So this distance here is modulus of A, and this is theta. By making use of cosine theta is adjacent over the hypotenuse, which means that this is going to be modulus of A cosine theta, which we see here, and this is the length of projection. So if it is length, it must always be positive. So if you were to add an overall modulus to it, then this will be modulus of A cosine theta, which is the modulus of this. Therefore, I can say that modulus of P dot A is the length of projection of OA onto OD. Okay, but like what I was saying, I don't think it is worth it. Usually this kind of geometrical interpretation question is just going to be 1 mark. Yes, correct. A cross B is equal to minus B cross A. That's why just now in part 2, I converted the just now in part 2, I converted the positive 1 over 3 lambda b cross a. I converted this into 1 over 3 lambda of minus a cross b, which is minus 1 over 3 lambda of a cross b that I wrote. Okay, you can also take a look at the theory outline under for vectors under dot and cross product. Specifically cross product, you will see a list. So in that list, you will see that a cross b is equal to b cross a cross a is equal to be equal to 0, and so on. It is a very good list. You should definitely consider understanding and then subsequently memorizing that list for your exam. For both the dot and the cross product. Okay, because in your prelim, very likely you're going to see 2 vectors question. One is going to be of this kind, where it is the kind of vectors where you're supposed to be mostly dealing with those without numbers, and you'll be using a lot of dot and cross product algebra. And then the second kind will definitely be those kind of vector question that has this. Okay, let's move on. Let's look at question number 6. Whoops. Yes, see, this is what I mean. That when I try to shift, I think my computer is undergoing like a very high load, processing the graphics of this whiteboard. Okay, question number 6. Question number 6, part 1, simple question. We are supposed to find dy dx. So let's first find dx dt, dy dt. Then dy dt divided by dx dt will be dy dx. So dx dt, this is going to be 25 of 2 sine t to the power of 1, then cosine t. So this is equal to 50 sine t cosine t. dy dt is simple. This is minus 2 sine t. So dy dx is going to be dy dt divided by dx dt. So it's minus 2 sine t divided by 50 sine t cosine t. This is going to be minus 1 over 2 cosine t. Let me write it down here. We will definitely be making use of it again. So minus 1 over 2 cosine t. Okay, part 1, 2 marks. Next, part 2. In part 2, at the point where t is equal to pi over 4, the tangent is going to be cutting the x-axis at P and the y-axis at Q. We are supposed to find the area of the triangle OPQ. The scenario is something like this. So let's say this is the y-axis. Let's say this is the x-axis. So we have a tangent to the curve at the point where t is equal to pi over 4. It is at this point, and according to the question, this tangent is going to cut the x-axis at P and the y-axis at Q. We are supposed to find the area of this triangle OPQ, which means that we should try to find the coordinates of P and the coordinates of Q. And after that, it is probably going to be just half times base times height. Okay, let's see how it goes. So let's find the equation of the tangent first. And that will be when t, according to the question, is at pi over 4. So when t is equal to pi over 4, let's try to find the x coordinate of this point. X is going to be substituting t as pi over 4. So it will be 25 of sine square pi over 4. This is going to be 25 of 1 over square root of 2 square. This will be 25 over 2. Then the y coordinate will be, when t is equal to pi over 4, it will be 2 cosine of pi over 4. So it will be 2 times of 1 over square root of 2. We can just simply write this as square root of 2. And we should try to find the value for dy dx also when t is equal to pi over 4. So that is minus 1 over 2 cosine of pi over 4. So this is minus 1 over 2 of 1 over square root of 2. So this is going to be square root of minus square root of 2 over 2. Minus square root of 2 over 2. This looks weird. Did I write something wrongly? Oh, I wrote something wrongly. This is wrong. This is 1 over 25 of cosine t. Okay, let me do a bit of correction to this. So this is 1 over 25 of cosine pi over 4, which is minus 1 over 25 of 1 over square root of 2. So minus square root of 2 over 25 is going to be the equation of the gradient. Yep, Benedict, I've done my correction. So equation of the tangent will be y minus square root of 2 is equal to the gradient of the tangent, square root of 2 over 25 of x minus away 25 over 2. And let me work on point P. So at point P, I'm going to, at point P. At point P, we are going to be letting y to be equal to 0. So at point P, y is 0, which means that we have a 0 minus square root of 2 is minus square root of 2 over 25 of x minus 25 over 25 over 2. So minus square root of 2 and minus square root of 2 can be cancelled. 25, I bring it over to the other side. So we have a 25 is equal to x minus 25 over 2. This tells me that x is going to be equal to 25 plus 25 over 2. That will be 75 over 2. Therefore, we know the coordinates of P is 75 over 2, 0. Okay, so this distance here is 75 over 2. Let's go for point Q now. At point Q, x is equal to 0. So letting x be equal to 0, we have a y minus square root of 2. This is minus square root of 2 over 25 of 0 minus 25 over 2. This will give us y to be equal to square root of 2. This cancel away, it will be plus square root of 2. So square root of 2, it will be square root of 2 plus square root of 2 over 2. So this is 3 square root of 2 over 2. So therefore, I know point Q will be 0 and 3 square root of 2 over 2. This tells us that this distance here is 75 over 2. And this distance here is 3 square root of 2 over 2. So the area of the triangle OPQ, where the area of triangle OPQ will be half times base, 75 over 2 times height, 3 square root of 2 over 2. This is equal to 225 over 4 square root of 2. Okay, part 2. And part 3. Part 3, we want to state the equation of the normal to the curve C when the normal is parallel to the x-axis. Let's do a little bit of visualization. The normal is parallel to the x-axis. which means that when we try to code the equation of this normal, the equation should look something that is like this. So when the normal is parallel to the x-axis, this tells me that the tangent, which is perpendicular to the normal, must be parallel to the y-axis. And when the tangent is parallel to the y-axis, that means for the curve dy dx is undefined, correct? Dy dx is this expression here. So for dy dx to be undefined, that is when cosine t is equal to 0. So for part 3, we are going to be letting, let me erase this, okay? So for part 3, we are going to be letting cosine t to be equal to 0. We will let cosine t to be equal to 0, t is going to be equal to pi over 2, or we now know that at this point here, cosine t is equal to 0. We can immediately find y, right? Because y happened to be 2 cosine t. So the y coordinate at this point will be 2, 0 is equal to 0. And this is going to be the equation, and this is going to be the equation of the normal. Okay? Because we have let the equation of the tangent be undefined, which we okay, maybe I should write this down properly. Okay, this looks like very confusing. So to start off, we should say something that is like, I'm going to let dy dx be undefined so that the normal can be parallel to the x-axis. This implies that cosine t is going to be equal to 0, which means that the y coordinate at that point is going to be 2 times of cosine t, which is 0. This is 0. Therefore, the equation of the normal will be y is equal to 0. Okay, let's take a look at question number 7 now. Hey, maybe there's really a chance. Okay, I also don't want to push. I'm just thinking maybe there's a chance that we can do question number 8. But I guess after we have finished 7, it is probably about time. So maybe we shouldn't push. Are there any of you who are studying ACJC? Is your math paper 1 like tomorrow? Or is it like, if it is today, then I assume no one from ACJC is here. But is your paper 1 like tomorrow? Anyone from ACJC? No? I should check with my ACJC student. They were telling me, but I've forgotten whether it is. I know it is either today or tomorrow. What? Okay, for hello. Are you sure your brain is already tired? Yeah, Claire, I have to agree. I think so far, right? This Hwa Chong paper is pretty okay. So far, it's really pretty okay. That's why I feel that this is actually a very fair and well set paper. Not one that is too difficult, but it is one that you still got to put in some effort to analyze and to digest the question. But it will be one where, I mean, it is the kind of paper where as long as you study hard, you know you're going to be rewarded. Okay, so I really like seeing this kind of paper during prelim. Well, let's do one more question, okay? Question number 7. And probably we can leave 8, 9, 10, 11, 12, the 5 question to Friday. We'll be streaming again on Friday 28th. So A, we are supposed to differentiate this 1 mark. So d dx of 2e to the power of cosine x over 2. This is going to be 2e to the power of cosine x over 2 and sine x over 2 and half. So this 2 can be cancelled. Oh, minus sine. So 2 can be cancelled. This is going to be minus e to the power of cosine x over 2 and then sine of x over 2. By the way, I think for those of you who are taking prelims, right, very likely the first half of the paper will be pretty easy. When the problem that students face, right, is because the first half was easy, so they sort of like slowed down. What you should be doing is to quicken up, when it is easy, and always expecting that a very difficult question or a very tedious question is going to be coming next. I think that is going to be a better way to manage our time during our prelim. Like for example, this Hwa Chong paper, I think the last few questions are actually quite long. If you were to look at the very last vectors, the last two questions, question number 11 is a differential equation question. It is a pretty long question. I've not done it myself yet, okay, but it looks very long, and the vectors question is just very intimidating. So I'll be expecting us to be spending some time reading the question also during the exam. But that's why for question 1 to 7, since it is easy, but if we were to slow down, it is actually going to be a disadvantage. So please remind yourself, okay, if it turns out to be easy, then please make sure that you like quicken up to do your exam. Oh, someone is missing Alvin Love Math on our stream. Hence, the question says, hence we are supposed to integrate half sine x, then e to the power of cosine x over 2 dx. Hence, we are supposed to integrate this. And I guess in order for us to make use of the previous part, I'm going to try to rewrite sine x as x over 2. So that will be half of 2 sine x over 2 cosine x over 2 e to the power of cosine x over 2 dx, which is going to be 2 and 2 can be cancelled. And I'm going to regroup them, okay, so that I can have this sine x over 2 together with this e to the power of cosine. So e to the power of cosine x over 2, I'm going to group it together with sine of x over 2. And then we have this cosine of x over 2 dx. I know from part 1, for whatever that we have integrated, whatever that we have differentiated here, we know that when we differentiate minus e to the power, when we integrate minus e to the power of cosine x over 2 sine x over 2, we know that this is going to give us a 2 e to the power of cosine x over 2 plus c, where this is from the first part. So I'm going to try to apply it here, but applying it for integration by parts. So I'm going to go for a cosine x over 2, and dv dx, which I'm going to be integrating, I'm going to go for e to the power of cosine x over 2 sine x over 2. Claire, why do you say this? Well, I'm assuming that you are definitely not from ACJC. Okay, but we did one ACJC paper that day, right? Okay, and that was a terrible experience. It was so difficult. I mean, it is doable, but to be doing that paper in the 3 hours, I think is really. I mean, the feeling is definitely not going to be like doing this Hwa Chong paper for sure. So this is going to be minus half of sine x over 2. And when we are integrating this negative, if I were to bring it over to the other side, that means v is going to be minus 2 e to the power of cosine x over 2. So rewriting this into the integration by parts form, will be uv. So we will have a minus 2 e to the power of cosine x over 2 cosine x over 2 minus integration of v du dx. These two multiplied together, so the minus will become positive, and 2 will disappear. This will leave me with a e to the power of cosine x over 2, then sine x over 2 dx. And this happened to be exactly the same as what we have done in part 1. So I'm going to make use of my result in part 1 again. So minus 2 e to the power of cosine x over 2. Cosine x over 2 minus, this will be minus 2 e to the power of cosine x over 2. Then plus c. So my final answer will be minus 2 e to the power of cosine x over 2, cosine x over 2 plus 2 e to the power of cosine x over 2 plus c. Okay, this is part 2. And let's finish up with B. It is a substitution question. B, we are supposed to integrate 1 over 1 minus e to the power of x by using this as a substitution. And let's do a substitution by literally doing an algebraic substitution instead of doing it as a formula or some kind of rules. I think it is easier to just substitute. What I'm trying to say is, for example, I know u is given to me as 1 minus e to the power of x. So I will just do whatever that I need in order for me to algebraically replace all the x by u. So here, I can already replace, so I'm going to just replace by u. So dx got to be replaced. I'm going to make x a subject here first. So e to the power of x, this is 1 minus u, which means that x is going to be ln of 1 minus u. So this tells me that dx du, this is minus 1 over 1 minus u, which is 1 over u minus 1. So dx, I'm going to replace it by 1 over u minus 1 du. So we are supposed to integrate this 1 over u minus 1. And I guess it is, at least it is obvious to me that one good strategy that I can make use of, it will be partial fraction. You can either use partial fraction, or you can probably also try to expand this and then do a completing square. But I'm going to just go for partial fraction. So I'm going to re-express this 1 over u minus 1 as a over u plus b over u minus 1. And we're going to make use of the cover-up rule that we discussed the other day. So to find a, I'm going to be covering up u, and I'll let the rest of the u be 0. So it'll be 1 over 0 minus 1. A is minus 1. And I'm going to find b by covering up u minus 1. And I'll let the rest of the u be 1. The u that caused the denominator to be 0. So 1 over 1. So b is 1. This tells us that this is going to be minus a is minus 1. This over u plus bb is 1. So 1 over u minus 1 du. So this is equal to minus ln modulus of u plus ln modulus of u minus 1 plus c. So this is minus ln modulus of u is 1 minus e to the power of x, plus ln of modulus of u minus 1. U minus 1 from here. U minus 1 will be minus e to the power of x, right? So u minus 1, I'll replace it by minus e to the power of x, then plus c. So this is minus ln 1 minus e to the power of x, then plus ln. Modulus of this can be seen as modulus of minus 1, modulus of e to the power of x. It is a little bit much, but it's more of like for my explanation. So modulus of minus 1 is positive. E to the power of x is also always positive. So this will turn out to be just ln of e to the power of x plus c, which is minus this 1 minus e to the power of x, then plus x plus c. It is not necessary for you to be writing down this. It is more of like for me to explain why this negative 1 can disappear. You can just directly go from here to here, or I think if you go from here directly to here, it is also fine. So let's take a look at this question. For this question over here, we are supposed to sketch the graph of this function fx. I've done a quick sketch using my graphing calculator. So I saw a shape that is, I can see that it is a shape that is like this. But one bonus that, one bonus is if you can actually deduce that this shape, the shape of this graph that we are looking at here, is part of an ellipse. Where that would be really a bonus, because for example, if you were to just take a look at the equation that is given, let me show you what I mean, okay? So for part 1, if you can just take a look at the equation here, if we were to let y be equal to this square root of a square minus x minus a square divided by 4. If we were to square both sides, we're going to be getting a y square. This is equal to a square minus x minus a square divided by 4. If I were to bring this over to the left hand side, we will have a x minus a square divided by 4 plus y square is equal to a square, and dividing by a square throughout, we will have a x minus a square divided by 4a square, which I can rewrite it as 2a square plus y square divided by a square is equal to 1. So I see the equation of an ellipse. In fact, we are drawing the top half of the ellipse. I've used a, which is according to the question, a is a positive constant. So I've used a as positive 1 way to sketch my graph. So from the equation of this ellipse, we can already see that the center is going to be at the point A0. When the horizontal radius is going to be 2a. So it will be a minus 2a. Then the other side is the same, so a plus 2a. And the vertical radius that we are looking at is going to be equal to a. So if you can see this, of course we can make use of the graph that is on our GC. But if you can see this, we can, I think it is even easier for us to be sketching the graph. So we will have our y-axis and x-axis here. So we have an ellipse. So something that is like this. According to the question, the domain is going to be between minus a and 3a, inclusive of both the values. The center of the ellipse is going to be at a0. And a is a positive number, so I know this is going to be on the positive x-axis. And because the horizontal radius is 2a, so a minus 2a, we will get this point here, which is at minus a0, where I'm putting a solid dot because x is bigger or equal to minus a. And a plus 2a gives us a 3a. So this point here is 3a0. And again, the domain include 3a. That is why here is a solid dot. As for the maximum possible point here, it is going to be where the stationary point is. And since I know the x coordinate is going to be a, and the vertical radius is a, so I know this must be x coordinate as an a, and the y coordinate will be 0 plus a. So here will also be an a. As for this is simple. We just need x, let x be equal to 0. Letting x be equal to 0, we have a square divided by 4. So a square minus a square divided by 4 will give us a 3a square divided by 4. And that will be a square root of 3 over 2a. So this is my graph for part 1. Like what I was saying, if you can actually see this as part of an ellipse, it is actually easier for you to be sketching the graph because you know you are sketching an ellipse, and it will be easier and more accurate for you to be quoting the coordinates that are necessary for the stationary points and where the graph cuts the x-axis. Next, part 2. Part 2, if the domain of f is restricted to minus a to k, such that f inverse exists, so the graph must pass the horizontal line test. Currently, the graph isn't passing the horizontal line test. What is the greatest possible value of k? I think this is easy. K can be a value that is here. K can be a value that is here. Maximum it can go is a. Beyond a, the graph is going to fail the horizontal line test. So for part 2, what is the greatest possible value for a? The greatest possible value for k. This is going to be equal to a. Next, part 3. Let me just erase this. I think we can start part 3 from here. So for part 3, so now from part 2, we know that k, the maximum possible k that we are working on, this k is equal to a, and we are going to be making use of this value of k for part 3. So let me rewrite the function fx. Function fx will still have the same expression, which is a squared minus x minus a squared divided by 4. As for the domain is going to be from minus a x all the way until k. The largest k is a. So we have this as our new fx. We are supposed to find f inverse in similar form. So what we need is an expression for f inverse, and we also need the domain of f inverse. I guess the domain of f inverse is easy. I can just see it from my graph. Domain of f inverse is going to be the same as the range of f. So looking at my graph, if I were to be restricting it from minus a all the way until x is equal to a, I'm looking at a graph that is like this. So if this is my new fx, looking at this, the range is going to be from 0 all the way until a, inclusive of 0, inclusive of a. So we will make use of this for the domain of f inverse later. Let's now try to find the expression for f inverse. So we will let y be equal to fx, which means that y is going to be this square root of a squared minus x minus a squared divided by 4, where x is supposed to be bigger or equal to minus a, less than or equal to a. And we're going to try to make x the subject. So y squared is equal to a squared minus x minus a squared divided by 4. So x minus a squared divided by 4. This will be a squared minus y squared. So this tells me that x minus a squared, this is going to be 4 of a squared minus y squared. So square root both sides, it is going to be plus minus 2. Then square root of a squared minus y squared. And a, when I bring it over after I've square root, I will have x to be equal to this. But x is a number that is less than a. Sorry, x is a variable that is less than a. So choosing between plus, minus, I'm going to choose minus so that x can be less than a. So this is minus 2 square root of a squared minus y squared. And this is because x is supposed to be less than or equal to a. So from here, we can deduce that the expression for f inverse. The expression for f inverse is going to be a minus 2 square root of a squared minus x squared. And x will be real numbers, and at the same time, x should be synchronizing it to the domain of f inverse. X should be bigger or equal to 0 and less than or equal to a. Okay, this is f inverse in a similar form. Next, part 4. For part 4, we are looking at G. Oh, okay. I'm actually not sure we were a little bit busy, so we still need to do a little bit of editing to Tuesday's stream. So probably by this weekend we will probably release the playback for Tuesday's live stream. Goodness, oversleeping, which means that you were sleeping like from 8 to 9:30. Isn't it a weird time to be sleeping? So okay, anyway, we are looking at G. So G is the transformed version of F. And the transformation is replacing X by 3 over 2X. So it's going to be a scaling by a factor of 1 over 3 over 2. So it is scaling by a factor of 2 over 3. We're scaling by a factor of 2 over 3 parallel to the x-axis. Okay, and the domain is also scaled. So minus A scaled by 2 over 3, we are actually getting this. 3 over 3A scaled by 2 over 3, we are going to be getting, scaled by 2 over 3, we are getting a 2A. Which means that for G, let me erase this, okay. We don't need this also. Let me erase this too. So the graph that we have currently, right, is the graph of y is equal to fx. It is not necessary to sketch, but at least it is not necessary to sketch now. But in a short while, I think the sketch is going to be useful. So let me just do a quick sketch for the graph of G, okay? It is basically the same as, the shape is going to be the same as this. So it's still going to be the top half of the ellipse. So we will still be getting a graph that is like this. But because it is this graph being scaled by a factor of 2 over 3. So what we have is going to be something that is like this. Here is going to be minus 2 over 3a, 0. Here is going to be equal to 2a, 0. The center, if I were to scale this by 2 over 3, the center is going to be 2 over 3a, 0. And the highest possible point here will be 2 over 3a, a. This is still going to be at 0 and square root of 3 over 2a. Okay, and this is the graph that represents gx. So for part 4, we are supposed to explain why the composite function gf exists. And according to how I have discussed in the last few weeks and how I did it on the Achevas TV theory outline, we will try to have a schematic that is something that is like this, that represents the composite function gf, which means that x first goes into f, then after that it goes into g. In order for the composite function to exist, we just need to make sure that everything that comes out from f, the range of f, is going to be entirely received by G. So it must be a subset of the domain of G. So let's try to quote the range of f, which we have already done it just now. The range of f is going to be from 0 all the way until a inclusive, from 0 all the way until a. And as for the domain of G, it is easy. It is already given to us as from minus 2 over 3a all the way until 2a. And because 0 is after this number, a is before this number, so the set of values here is indeed a subset of the set of value for the domain of G. Therefore, we can say that the composite function gf exists. And we are supposed to find the range of the composite function gf. So to find the range of a composite function gf, one good way is to take a look at just the last function g. And if I were to look at the last function g, okay, let me use red color. So I'm going to try to look at this last function here. So if I were to look at this last function g, I'm going to use method 2 from the Achevas TV outline, method number 2, to find the range of the function. On the Achevas TV theory outline, I have two methods. The first method is to actually generate the composite function of the entire, generate the expression of the entire function. The other one is to just look at g. So if I were to just look at G, one thing that I know is that the domain of G is still going to remain as the domain of G, which is from -2/3 all the way until 2a. So if whatever that goes in is the same as the domain of G, whatever that comes out is going to be the range of G. But that is not what I want. What I want is for what that comes out from G to be the range of the composite function gf. So in order for this to happen, what we will do is we let what that comes out from f goes into G, just like how when it is connected as just like how it behaves in a composite function. So for G, I'm going to let what that comes out from f, which is the range of f, so from 0. So the set of values that is from 0 all the way until a will go into G. And when I make sure that this happens, what that comes out from G will be the range of gf. So I'm going to use this method number 2. In case some of you are still not very familiar with this method number 2, please go and check out the video that is on the Achevas TV outline for composite function, range of a composite function. So now referencing it back to the graph of G, I know the input is going to be from 0 to a. 0 is here, and a is somewhere here after 2/3. So from 0 all the way until a is going to go into the function, which means that the graph that I'm looking at is going to be this, passing the highest point, then coming down that little bit. And I know this point is at a y coordinate that is higher than this. How do we know this? Because from here to here is 2/3a. But from here to here, from 2/3a to a, this is at the point a, okay? From 2/3a to a, this is just 1/3. So it comes down less. It comes down less than it comes down as compared to this. That's why this is at a lower point as compared to this. And this is going to tell us what is the range, because it is from the lowest possible y coordinate to the highest possible y coordinate. That's why looking at this graph, we can then deduce that the range of the composite function gf from here, it is going to be from square root of 3/2a, inclusive of this value, all the way until the highest possible point, which is a. Okay, this is the range of the composite function gf. Three over 2x into f. Okay, there's this question, right? 3/2, yes. Okay, so G is yes. So G is a transform version of f, where we replace x by 3/2x. That is why it's going to be a scaling by a factor of 2/3 parallel to the x-axis. Okay, it is a scaling by a factor of 2/3 parallel to the x-axis. So from fx, this is a graphical transformation question. From fx to f 3/2x, which is our new function gx. This is going to be a scaling by a factor of 2/3 parallel to the x-axis. So that's why from this graph of y is equal to fx, we scale it by 2/3, actually compressing it by 2/3 times. So compressing it by 2/3, so or scaling it, a better phrase will be scaling it by 2/3. So this scale it by 2/3, we get this as the center, and then this scaling it by 2/3. This we also scale it by 2/3. So all the x coordinate is scaled, the y coordinate remains exactly the same. Okay. So we are using method number 2 to find the range of a composite function. And next, let's take a look at question number 9, which is an APGP question. And in this question number 9, actually question number 9 is very simple, but I have to say that if we were to be doing this question in the exam, it is somewhat confusing because of the situation that is given to us. Let me show you what I mean, okay? How you get A? I didn't manage to get A. Because somebody is asking about how am I going to get A? So A remains as A. I didn't change A at all. how you get A. Did I interpret your question wrongly? In case you are wondering about this A here, right? This A here is because for G, in the composite function, I'm letting what that comes out from F goes into G, and what that comes out from F is from 0 to A. So from 0 to A is going to go into the graph of G, and this is going to represent for me what that is supposed to be coming out from G in the composite function. Okay, so I'm assuming, I'm not sure, but I'm assuming that the A that you're referring to is this A over here. Okay, so this A is actually obtained from the range of F. Okay, in a composite function, the range of F is going to go into G. So this is the range of F. Okay, let's move on to look at question number 9. Like what I was saying, it is actually a very okay question, like really pretty okay. The problem is this LED 1, LED 2. You know, the numbering is I mean, at least for me personally, okay. I thought the numbering was the slight confusion for myself when I was doing this question. Let's see whether you guys are going to be a little bit confused by the numbering also. So we have LED 1, 2, 3, and so on. And the distance that is between them is going to be D for the distance that is between LED 1 and LED 2. Then from LED 2 to LED 3, this is 4 over 5 D. And this 4 over 5 is going to continue for the rest of the distances. So we are talking about a GP, correct? We are talking about a GP. So for GP, I am going to just call this here. Okay, this is where it gets confusing for myself. Okay, I'm going to call this the first term of GP as U1. So this is U2. That means let's take note, okay? U1 is going to be the distance that is between LED 1 and LED 2. U2 is going to be between 2 and 3. Which means that if I were to say something that is like S2, S2 is U1 plus U2. But S2 represents the distance that is between LED 1 all the way until LED 3. Okay, so this is the way that we are going to be viewing this question, okay? Let me very quickly repeat, because L1 is this distance, L2 is this distance, S2, which is L1 plus which is U1 plus U2, which is the distance not between LED 1 and LED 2, okay? This S2 is the distance that is between LED 1 all the way until LED 3, okay? S2. Let's see whether this is going to help us to diagnose this question a little bit better. So part 1. Part 1, the distance that is between 8 and 9 is 56.2. So the distance that is between 8 and 9, for example, between 2 and 3 is U2. So between 8 and 9 is U8. And U8 is, if I were to be looking at a GP, the first term is D, the common ratio is 4 over 5. So 4 over 5 to the power of 8 minus 1. This is equal to 56.2. This will help us to immediately solve for D. I think this is, as long as the interpretation is correct, I really think this is like extremely simple. So 268.0, this is to 1 decimal place according to what the question requires. Then part 2. Part 2, I want to find the theoretical maximum length of the wire. So the theoretical maximum length is if I can just continuously add all the distances between the two LEDs together. So we will do a sum to infinity. So the theoretical maximum length. Okay, we will do a sum to infinity. and that will be the first term, which is D26. Let me go for 5 SF, okay? So 267.98. So the first term divided by 1 minus the common ratio, which is 4/5. So this is going to get me a 1339.1. Again, this is to 1 decimal place. Next, part 3. Okay, for part 3, the LED is going to consist of 3 colors: red, orange, yellow, and it is going to go in accordance to the order of this red, orange, yellow, starting from LED 1, which means that, for example, if I have this is U1, U2, U3, U4, U5, U6, let me just go on, okay, U7, U8, and let's say one more, U9. It's just so that it is easier for us to have to understand what this question is saying. So this is supposed to be like red, orange, then yellow. It's going to continue Roy again, then another Roy again. Oops. Okay, so you'll just continue and continue and continue. So we have red, orange, yellow, red, orange, yellow. The term of the G's, the terms of the GP, the consecutive LED lights, do until U infinity. Okay, I'm a little bit confused by the by what you guys are saying. The terms of the GP's distance of the consecutive LED lights. Okay, I assume that is not a question. So for part 3, we want to find the color of the LED that is going to be closest to the point where the wire is of a length 12.9. So L1, L2, blah 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 blah, all the way until, I don't know, like maybe somewhere. Then we reach a distance. Okay, let me just draw properly. So we reach a distance of 12.9. We don't know which LED is nearer to this, because it can be the LED that is before. So, oh, okay, I shouldn't use U1, U2, U3, U4. Oh goodness, I wrote so many, right? But then it is incorrect. But I think I know what Claire is saying already. It is the wrong, it is my wrong notation. So we are talking about LED 1, LED 2, LED 3, L4, L5, L6, L7, L8, L9, which means that in order for us to find the LED that is nearest to this point here, it can be either Ln, I don't know where it is, or Ln plus 1. Okay, either the one that is before or the one that is after. So in order for me to do this, I'm going to try to do a sum Sn, for example. So I'm going to do a sum of a GP. The sum of the GP will be 267.98, the first term, then 1 minus the common ratio, which is 4/5 to the power of the number of terms. Number of terms is n number of terms. So this divided by 1 minus 4/5. Okay, this is the distance. Let me do a quick simplification to this and a quick simplification to this. Did I simplify? Oh, I didn't really simplify. Okay, anyway, this is 267.98, 1/5, so multiply by 5, 1 minus 4/5 to the power of n. So this represents the total distance, and we want the total distance to be as close to this 12.9 as possible. So I will press this into my GC. Let me show you what I've gotten, okay? So if I were to press this into the GC, right, I will get something that is like this. Okay, I will generate the table. So this is what I have gotten. So Y1 is this entire thing. When I press Y equal in Y1, I'll press this in. So this 1 minus 4/5 to the power of x. So all these Y1 here are the total distances between the LEDs, all the way until the all the way until S13, S14, S15, and so on. So I can see when it is S14, okay, I can see from here, when it is S14, 1281, that is just before this, because this is 1290 cm. Okay, this is given to us in meters, so 1290 cm. To generate the table, we will just press Y1 as, oh, actually I have a screenshot. So let me show you my screenshot for generating the table. Okay, it is just simply this. Okay, I will press this entire expression into the Y1 of my calculator. Then I'll press second graph to generate a table. So X represents N and Y1 represents the total distance. So from here, after I press this into my calculator, generating the table, I'm interested in these two numbers here. Okay, I'm interested in when the total length is 1281, because it is very, very close to this. That means from the table, right, I can see that S14 is 1281. And like what we were saying just now, right, we were saying when it is S2, which is U1 plus U2, S2 represents the distance that is between LED 1 all the way until LED 3, not 2, but LED 3, which means that S14 is the distance that is between LED 1 all the way until LED 15. So now we are looking at LED 15. LED 15, that means this implies that LED 15 from 1281 to 1290 is 9 cm from the point. And then this S15 is 1292.8, and S15 is talking about LED 16, and LED 16, which gives a total distance of 1292.8, is just 2.8. Okay, so which LED is going to be the closest possible to this 12.8? It is going to be LED 16. Okay, so LED 16 is the nearest. And if LED 16 is the nearest, what is the color that we are expecting? If it is LED 1, LED 2, LED 3, ROY, it means all the way until LED 15, it is at Y, correct? So which means that LED 16, it should be red. Okay, so this is my answer. Yes, I really suggest that if you are using a table to do your calculation, it is better to quote the numbers that are on your it's better to quote the numbers that you see in the table. That's why I'm quoting the number here. S14 is equal to this, S15 is equal to this. When you usually quote the numbers, you must at least quote a few numbers that are the numbers that you want, and maybe you should quote a few numbers that is before and after. Okay, so one way that we can try to present our table, right, is we can do something that is like this. Presentation wise, I think we can do this N, and we do a S N. So I know 14 and 15 is what I want, so I'm going to quote 13, 14, 15, 16. So when it is 13, in my presentation I'll write 1266.2. Then when it is 14, I have 1281, 15, 1292.8, and 16, 1302.2. So I know 14 and 15 are what I'm interested in. In fact, 15 is what I'm looking for, and this directs me to LED 16. Okay, I see a very funny question. I'm going to tell you, okay, but I think you're you're going to feel sad if I were to tell you how I get 9 cm. Okay, but I'm still going to tell you anyway, okay. I get 9 cm because S14 is 1291. So 9 cm is just simply this 12.9. So 1290 minus 1281. This is 9 cm. I mean, it's just simply 9, like this point is 9 cm after LED 15. You know, similarly to get this, right, it is 1292.8 minus away 1290, which is the point that the question is talking about. Okay, for example, if it is L7, if it is L7, right, I know every 3 times it's going to just repeat. Every 3 times it's going to repeat. So L7 will be red color because when it is L6, it is at Y. Your multiples of 3, correct? Which means that if I talk about L16, there will be 15 of the 3s. So when it is at LED 15, oops, what am I writing? When it is at LED 15, it is going to be a yellow, which means that LED 16 is going to be red color. Okay. So similarly, like LED 9 should be yellow color. Then LED 10 should be red color. Let's try to apply this for part 4 also, because we are going to be using almost the same strategy. So for part 4, we want to make sure that all the distances, right, must be a minimum of 1 cm. Great. Okay, the distances must be a minimum of 1 cm. And if you think about it, right, if you want the minimum distance between any 2 consecutive LEDs to be 1 cm, that means it is actually the last LED must be more than 1. The distance between the last pair of LED must be more than or equal to 1 cm, correct? Because you know why? Because the common ratio is 4/5. So basically the distances become shorter and shorter and shorter and shorter. So I just need to make use of the very last distance, which is, let's say, UN, and I'm going to let this UN be bigger or equal to 1. So this last distance is going to be A as a first term. First term is 267.98, and common ratio is 4/5 to the power of n minus 1. Where this is the expression for the last term, that is the last distance, and I'm going to impose and make sure that this is bigger or equal to -1. And just like what we did for Sn, right, we will press this into the calculator. And we will generate a table. And in this table, I will be looking out for all those distances that are bigger or equal to 1. So all these are bigger or equal to 1. Until 26, it is still going to be bigger or equal to 1. The moment when it goes to 27, it is going to be less than 1. So the maximum possible number of distances that I can look for, right, is all the way until 26. That means I can go all the way until U26 only. After U26 is going to be a distance that is going to be that's going to be less than 1 cm already. So I can also, for presentation wise, I can say something that is like this. From my GC, I will really encourage you to at least write down the values that you see on your table, and X is going to be representing N, and Y1 is representing this UN. Okay, this is UN. So this is where I am. This is the number that I'm interested in. So in my presentation, 25, 26, and 27. For 25, this is 1.2655. 26, this is 1.0124. And then it is going to be less than 1 cm. So I have this obtained from my table. Let me erase this table. So this tells me that U26 is going to be the last distance, and U26, like U2 points to LED 3. So U26 points to me the last LED. The last LED last LED is supposed to be LED 27, and LED 27, it is a multiple of 3, so LED 27 is a yellow. Okay, LED 27 is a yellow. With LED 28, it is going to be a red color. Okay, that's why if you were to look at a solution to this question, I don't think it is very difficult if you were to just simply look at the solution. But when you process this from scratch during the exam, the challenge is there because you are reacting a lot to the logic and the common sense that the question is trying to involve you for you to participate and come up with all this logic. So in a way, I will feel okay, this is quite a challenging question to do in the exam. Okay, because for example, when we were saying U2, somebody is asking why not LED 26. Okay, because like what I was saying just now in the beginning, right, we must be very careful about this question, because the numbering by itself is the challenge, not exactly the calculation, but the numbering itself. So if you were to look at U2 is not LED. Okay, U2 is the distance that is between LED 2 and LED 3. That's why U2 actually tells you that the last LED is LED 3. U1 tells you that the last LED is LED 2. That's why this, which is U26, tells you that it is LED 27, that is the last LED. Okay, because U26 is the distance that is between LED 26 to LED 27. So this distance here is U26. Okay, and I will agree with Claire, right, that this question is tedious, but it is sort of like tedious in the processing kind of way. Why is UN more than or equal to 1 is the difference. Why is UN more than or equal to 1 is the difference? Oh, actually it is exactly according to what the question says. Where I have no way of answering you any better than what the question is describing. So your question, right, can be actually answered by the question itself. Okay, because the question says that the distance that is between the two LED, it must be minimum 1. So all the distances U1, U2, U3 all must be minimum 1. And because we are looking at this as a GP with a common ratio of 4/5. So I know the next one is going to be shorter, the next one is going to be shorter, the next one is going to be shorter. So we saw this in the table also. You will just get shorter and shorter and shorter and shorter. And when we go for U27 is the distance that is between LED 27 to 28. Okay, it is going to be less than 1 already. So the last LED, right, the last distance cannot be U27. The last distance has to be U26, so that we can maintain the distance to be minimum 1 cm. Okay. Because this is a very how should I say, this is a question that depends very, very heavily on how you read and process the information that is given to you by the question. So for some of you who find who who starts to get a bit confused, when you're reading, when you're working on this question, my suggestion is to know that the nature of this kind of question require you to participate in the information that the question gives you more than the APGP idea. So you cannot just depend, on the fact that you know about APGP, you know about the formula, and not spend enough time reading the question. And the challenge is to actually read the question and to be able to react according to the information that is given to you by the question. When this reaction, I find, whichever student that can, when a student can react properly to this kind of situation, that is when they will actually push their grades higher and higher and higher for questions that are like this, where most of the information has to be obtained from the question on the spot during the exam itself. Okay, to give you the best possible answer, my suggestion is for you not to become an LED. My suggestion is for you to become the distance that is between the LED. Okay, I think that will actually make you understand this question better. Okay, so be the distance that is between LED, okay? Not the LED. If you be the LED, you're going to be very confused. Okay, be the distance. Okay, next let's take a look at question number 10. 10 is okay. 10 is just tedious, but it's not a very difficult question. So 10, we are supposed to solve this simultaneous equation. We have V is equal V. Let me write it down. So V plus IU is equal to 2, and the other equation is AV minus 2U. This is equal to 3I. I'm going to solve this pair of simultaneous equation using secondary school's elimination and substitution. So looking at the situation that I have here, right, I'm going to make V the subject. V is 2 minus IU. So this I'll call it equation number 1. This I'm going to call it equation number 2. And I'm going to substitute equation number 1 into equation number 2. So putting it inside, it will be A of V, which is 2 minus IU, then minus 2U. This is equal to 3I. We have 2A minus 2IU minus 2U. This is equal to 3I. I think I'm going to bring this over to the right hand side. Then this 3I, I'm going to bring it over to the left hand side. So this will give me a 3A minus 3I is equal to, this will be 2 plus 2I multiplied by U. Did I write wrong? Oh, it's not 2I. This is minus IAU. Okay, I'll write it this way. So this is going to be 2 plus IA multiplied by U. Okay, if I were to bring this over to the right hand side. So what is U? U is going to be equal to 2A minus 3I divided by 2 plus IA. And we are going to try to rationalize this because we are supposed to give our answers in the form of x plus iy. So let's rationalize this by multiplying the numerator and the denominator by 2 minus ia. And the denominator will be 2 square plus a square. Then numerator will be this times this. We have a 4a. This times this. We have a minus 2a square I. Then this times this. We have a minus 6i. This times this. We have a positive I square, which will become minus 3a. So if I were to group all the rails together, it will be 4a and 3a, that will be a. So a over this, 4 plus a square. Then plus I of the other one. The other one will be this minus 6 minus 2a square. minus 6 minus 2a square, this divided by 4 plus a square. Okay, this will be u. When can you start comparing real and imaginary? Hang on, I'm wondering whether this is somebody is asking when can we start comparing real and imaginary. Hang on, I think I know what is your question. It seems like an easy question, but just in case, let me think about something. Okay, nope. Okay, so to answer you, right, you can start to compare real to real and imaginary to imaginary when one side of the equation is real plus I imaginary, and the other side of the equation is also going to be a real plus I imaginary. So when you have a form that looks exactly like this, that means x1 is going to be equal to x2 and y1 is going to be equal to y2. And that is why when you are trying to do all the rearrangement, you're basically regrouping on the left hand side all the reals together and all the imaginaries together. The same you will do for the right hand side to group all the non-i's together and all the i's together. I don't think it is a very common mistake, but a possible mistake is for students to try to group all the x together and all the y together. Okay, this is not the case. We are not doing real number because so what our aim is, our aim is to group all the reals together. That means all those that doesn't have i's together and all those that have I together. Okay, so once that happen, then real is real, imaginary is imaginary on both the left and right hand side of the equation. So we have u is equal to this, and I'll just substitute this back into v to find v. V is 2 minus iu, which is a over 4 plus a square plus I of minus 6 minus 2a square over 4 plus a square. So we have 2 minus I times of this a over 4 plus a square. Then this it will be minus I square, which will become a positive 1. So we have a positive minus 6 minus 2a square divided by 4 plus a square. So I'm going to try to combine these two together. So we have 2 multiplied by 4 plus a square, then minus 6 minus 2a square divided by 4 plus a square plus I of this negative, I'm going to bring it in. Okay, so minus a over 4 plus a square. So my final answer is 2 times 4, 8. 8 minus 6 is going to be 2. Then 2 times a square, 2a square minus 2a square, it will be 0. So I have a 2 over 4 plus a square plus I times of minus a over 4 plus a square. Okay, u and v is a okayish question, a little bit tedious, but as long as we try to be a little bit more careful, it should be okay. Next, let's take a look at b. B is independent of part A, so I'm going to erase the solution entirely. Okay, so for B we are given a polynomial and we are given a factor, which means that one of the roots of this polynomial will be when I let this factor be equal to 0, x plus k is equal to 0, which means that x is equal to minus k is the root of this polynomial, which means that when I substitute x as minus k, it is going to satisfy, it will be equal to 0. And I'm going to make use of this to attempt to find k. So letting x be equal to minus k, because minus k is a root of this equation, we will have a b of minus k cubed plus 12b plus I of minus k square plus b plus 12i of minus k plus 12b. This is equal to 0. And here is where, for really, I'm seeing Claire says that 4 marks for a very easy question. I thought it is very tedious, that's why they gave 4 marks. Because they gave this A, which prevents you from doing simpler calculation. But it is very, very easy. I have to agree. This is very, very easy. But there's nothing that requires us to do additional analysis for this question. It is almost like a simple tutorial question. And for the person who was asking me about, when can we do the comparison? So I'm going to do a little bit of comparison, the real to real, equating the real to real, imaginary to imaginary. So for this equation here, I'm going to first try to do this rearrangement first. I'm going to group all the non-i's together and grouping all the i's together. Let's see. For the left hand side, okay, let's do that grouping first. So on the left hand side, we have a minus bk to the power of 3. And minus k squared is k squared. So I have a plus 12bk squared plus I of k squared. Then this is minus bk and minus 12k minus I 12k. Then plus 12b. This is equal to 0. I'm going to group all the non-i's together, which is minus bk to the power of 3 and this plus 12bk squared, and this minus bk, and this plus 12b. Okay, all the non-i's I've grouped together, and for all the i's I'm going to group together also. We have a k squared, and then this minus 12k, and this is equal to 0. And we can see 0 as 0 plus 0i. So the moment when we have grouped the left hand side into the real plus I imaginary, and we can see the right hand side is also a real plus I imaginary, then this is going to be equal to 0, and this is going to be the other 0. And of course, I'm going to use the second one, which is this k squared minus 12k. This is equal to 0. And because the question says that k and b, they are non-zero constants. So since k cannot be equal to 0, I'm going to divide throughout by k. This gives me a k minus 12 is equal to 0. I will now be able to solve for k. K is equal to 12. Okay, let me record it down here. K equal to 12. Next, part 2. Part 2 is sort of like weird. Okay, we are supposed to show that the roots are purely imaginary, and I don't think it is easy for us to immediately see how the roots are going to be purely imaginary. So what we can do is to at least try to find the roots first. And let's take a look at the roots, and let's see whether after I can do that, is there any way that I can discuss so that I can prove that all the roots, there are just 2 roots. Okay, all these 2 roots are going to be purely imaginary. So we have this equation, bx squared plus ix plus b is equal to 0. I'm going to apply the quadratic formula. So this is minus I plus or minus square root of I squared minus 4 this minus 4ac divided by 2a. So I have this. Please take note, b is a real constant. So I have a minus I plus or minus square root of this. I squared is minus 1. So I have a minus 1 minus 4b squared divided by 2b. And we're supposed to discuss that this root here is a purely imaginary number. So if the complex number is x plus iy, we're expecting it to have no this portion. It is just going to be this portion here. Okay. So how I can, did he just say that divide by 2a? Yeah, divide by 2a as in like divided by 2a coefficient ax squared plus bx plus c. It is the quadratic formula. So this is equal to minus I plus or minus. If you were to look at this, we can rewrite it as square root of minus 1 of 1 plus 4b squared, and this divided by 2b. So this is minus I plus or minus, what is square root of minus 1? It is I. And I will be left with a square root of 1 plus 4b squared divided by 2b. And 1 plus 4b squared is always going to be positive, right? Especially b is also given to us as a real constant. So this is always going to be positive, which means that square root of this is always going to be a real number. So now we have shown that whatever that I've gotten here, if I were to just factorize out I, we have a real number. We have two possible real numbers, minus 1 plus or minus square root of 1 plus 4b squared divided by 2b. So this is a real number multiplied by I. That is why the roots of this equation is always going to be purely imaginary. Okay, this is part 2. It is purely imaginary. And for part 3, we are supposed to re-express fx as 3 linear factors. This is x to the power of 3, so we will be expecting 3 roots. That is why we should have a maximum of 3 linear factors. And since one of the factor is already given to us as x plus k, I'm going to either do a long division to find the other factor, which is going to be a quadratic factor. I can do a long division, or we can do a comparison. Let's try a comparison, okay? That means if I were to say fx, which is equal to this, bx to the power of 3 plus 12b plus I, x squared plus b plus 12i x plus 12b. Sorry, I have to laugh at this question. I have to laugh at this question because if you are taking the prelim, then really OMG, okay? Because linear factor are like this. This is a linear factor. That means if it is x minus, for example, if it is x minus k, this is going to be a linear factor. A quadratic factor will be like this plus ax squared plus bx plus c. This will be a quadratic factor. So for example, this here, right? This, okay, I can express it as a linear factor, x plus k, multiplied by another factor, and this factor is going to be a quadratic factor. It is going to be a quadratic factor because we have an x to the power of 3. So this must be a quadratic expression. It's like 6 is equal to 2 times 3. That means 2 is a factor, 3 is also a factor. So this is a linear factor. This is going to be a quadratic factor. And for this quadratic factor, the coefficient of x squared should be b. Because bx squared times x is going to be bx to the power of 3. And k, oh sorry, I should have replaced k. Because we know k is equal to 12, right? So it is x plus 12. So plus something x, which I don't know, but I know what is this last number. Because 12 multiplied by this last number should give me a 12b. So this last number here should be a plus b. So 12 times plus b is going to give me a 12b. So now my next objective is going to find the coefficient. I'm going to call it c, okay? So to find c, we can try to use a comparison. So for example, if I were to compare both this and this by comparing the coefficient of x. Okay, on the left hand side, what is the coefficient of x? It is b plus 12i. On the right hand side, what is the coefficient of x? How am I going to be getting coefficient of x? It will be x times b, correct? So the coefficient is going to be b. Then the other one is going to be 12 times cx. So plus 12c. So the coefficient of x on the right hand side is going to be b plus 12c. Comparing to this, that means 12 is going to be equal to 12c. This tells me that c must be equal to I. sorry, 12i is going to be equal to 12c, so c must be equal to I. And that is why I can see fx to be x plus 12, and then bx squared plus c, which is I, x plus b. And this is the quadratic factor. This is the linear factor. Okay? Linear factor because this is a linear expression. That's why it's called a linear factor. Quadratic factor because this is a factor and this is a x squared. That's why it's a quadratic factor. And we are supposed to continue to factorize this into two linear factors. How am I going to do that? I'm going to make use of this, which we have just found. So I'm going to write something, but in case you think that I'm making an error, right, just hang on for a second, okay? So it should supposed to be this. And from here, right, just now we have deduced two roots. The two roots are -1 plus or minus square root of 1 plus 4b squared divided by 2b. So one of the factor is going to be x minus -1 minus square root of 1 plus 4b, sorry, it is going to be this I. So this divided by 2b I. Then the other linear factor will be x minus -1 plus square root of 1 plus 4b squared divided by 2b I. Wait, but this is incorrect. I've seen quite a lot of students, including teachers, right, making this mistake accidentally. This is incorrect because if you were to expand this, you're going to get x times x times x, which is x to the power of 3. But fx is bx to the power of 3. So let's not forget the coefficient b in front. Okay, this b. So my final answer will be b times of x plus 12. Then, okay, I think I can multiply this in. So plus 1 plus square root of 1 plus 4b squared divided by 2b I. Then x plus 1 minus square root of 1 plus 4b squared divided by 2b I. Okay, this is expressing fx as three linear factors. Again, linear factors because this is x, x, x. Quadratic factor because this is x squared. Factoring out -1 is also one. Factorizing out -1. When did I factorize out -1? Okay, I'm not sure what this is. Wow, Alvin, you're the one person who attends the live stream all the time. Okay, next, let's take a look at 11. Mm, 11 is a maximum minimum question. 11 is actually very simple, I think, provided that you do something that is a bit similar to the APGP question that we have just done. To prove that the root is purely... Oh, okay. I get what you mean. With the factorizing out -1 to prove that. Okay. And factorizing out -1, I mean, just to let you know that it may not work all the time. Okay, it happened to work here because after you have factorized out -1, the expression that was left happened to be 1 plus 4b squared, which is a always positive expression. So you know when you do a square root to 1 plus 4b squared, it's going to be a real number. If there were to be any chance that the expression, even after you factorize out -1, right, if there were to be any chance that that expression is it can be negative, then it wouldn't work. So it just so happened that it works because 1 plus 4b squared is always positive. Okay, next let's take a look at 11. Like what I was saying, you must I mean that is the thing about H2 math. You cannot just simply put in theories without capturing the context of the question. So let's see whether we can do something that is like the LED question to this. Okay, if you can do it for this, then this question will be a very, very simple question. So according to this question, x is going to be the depth of the liquid that is inside. So if let's say the liquid is here, then x is going to be this. And the surface is r. The surface the radius of the surface is r. Okay, so this is r. Now for part A, x is supposed to be bigger than 4. So if x is bigger than 4, I know that the depth is going to be, the surface is going to be in this cylindrical area. Okay, if it is more than 4. So I want to find the rate of change of the depth. I want to find dx dt. The question tells me that the liquid is dripping out at a constant rate of 18 cm cube per minute. So if we were to talk about the volume that is inside as V, that means according to the question dV dt, this is equal to minus 18 with a constant rate of minus 18. So for part A, let's try to look at the volume, and then from the volume we try to differentiate with respect to t to get a x. So I'm going to try to relate volume to x, and this volume, if I were to relate it back to x, it is going to be the volume of the cone, and the volume of the cone is fixed because the height goes beyond the cone. So this will be 1 over 3 pi r. R is 5 over 2 pi r square h. 4. This is the volume of the cone, then plus the volume of the cylinder, which is pi r square height. Height is going to be x minus 4. Oops, r is actually fixed also. R is 5 over 2. So 5 over 2 square of x minus 4. Okay, this distance here is x minus 4. So for V, not super necessary, but I think we can actually still simplify this. So I have this pi, then plus a 25 over 4 pi of x minus 4. So from here, we can try to do a differentiation with respect to t. On the left hand side, if I were to differentiate it with respect to t, it is dv dt. On the right hand side, this will disappear. Differentiating this, we will be left with a 25 over 4 pi of dx dt. Differentiating 4, it is going to be equal to 0. So this tells me that dv dt, this is equal to 25 over 4 pi of dx dt. Wait, so I think this is like really simple because so what is the rate of change of the depth? That is when dv dt, when dv dt is minus 18, then 25 over 4 pi of dx dt, this is minus 18. So I can now find dx dt. dx dt is simply going to be minus 72 over 25 pi. Okay, this is part A. Next, I want to find the rate of change of r when x is equal to 2. Find the rate of change of r, find dr dt when x is equal to 2. And can you see that when x is equal to 2, that means the depth is going to go to the, the depth of the liquid is going to be sinking to this level here. So it is basically anything that is within the cone only. The cylinder that is on top doesn't really matter anymore. So for part B, we are going to redo the entire scenario by focusing on just the cone. So for part B, if I were to focus on just the cone, hang on, let me draw it a little bit better. So if I were to focus on just the cone, we are looking at it as something that is like this. So if I have the center of the cone as here, I know I know that this distance here is 5/2, and this distance here is r. Here is the depth of the liquid that is inside, so this is x, and here is 4. I am pretty sure we are going to be making use of similar triangles, but anyway, I'm going to look at V first. V is the volume of the liquid that is inside, is 1/3 pi r square x. The height is x, and we are supposed to work on the rate of change. So I will suggest that you take this equation as it is and then just do a dv dt. Differentiating the left hand side with respect to t, I have this. Differentiating the right hand side with respect to t, applying implicit differentiation, r square, then this product rule, then plus 1/3 pi. Differentiating r square, we have 2r, dr dt, multiplied by x. Of course, you can try to make x the subject by using similar triangle. For example, r over 5/2, this is going to be equal to x over 4. Going to make x the subject, substitute into here, then do a dv dt, that is fine also. Okay, but let's say I do it this way. Then from here, I'm going to try to find dr dt when x is equal to 2. So when x is equal to 2, in order for me to find dr dt, we need to first get this. We need to get this, we need to get this, we need to get this and this, then we will be able to get this. Okay, so I'm going to try to one by one cross out the quantities that I'm going to be finding. The first quantity that I'm going to cross out, I guess, is this, because x is already equal to 2. The next one that I can cross out is, I guess, dv dt. I can cross out because the question tells me that dv dt is minus 18. So this is done. R I can also find, because from here I know r is going to be equal to 5/2 if I were to multiply across 5/8x. So r is going to be 5/8 times 2. This is 5/4. So r is also done. Dx dt, okay, dr dt is supposed to be what I'm finding, so it would definitely be the last. But then dx dt, in order for me to find this, I guess I can make use of this, because from here dr dt, this is equal to 5/8 of dx dt. So this tells me that dx dt, this is equal to 8/5 of dr dt. So with this, I guess I can also substitute and replace dx dt by this. Well, then we will be able to get an equation that is in terms of just dr dt. We should be able to solve for dr dt. So if I were to substitute in minus 18, this is equal to 1/3 pi of r. R is 5/4 square. Dx dt will be 8/5 of dr dt. Then plus 1/3 pi of 2r. R is 5/4. Then we have a dr dt multiplied by x, which is 2. Then now I have an equation that is in terms of just dr dt. If I were to do a quick simplification, I have a 5/2 pi of dr dt. This is minus 18. This will help me to solve for dr dt. And this is equal to negative 36/5 pi. Can we find dvdr? Yeah, you can definitely find dvdr because you can be replacing x that is here. You can replace x that is here by 8 over 5 r. Then you will find v in terms of r cubed. Then you can find the dvdr, and then of course use the rate of change equation from your secondary school to quote for dvdt. Okay, this is not necessary. It is something that I encourage, something that is like this. Not so much for this question because this question is actually pretty simple, but I encourage doing something that is like this when a question gets sort of like complicated. I can't show you here because this question is like really too simple, but when the question get complicated, doing something that is like this will actually make it like way simpler than to use the rate of change equation from your secondary school. Next, let's take a look at C. So for part C, let me shift this up a little. Oh, part C, right? Okay. For part C, we are going to be focusing on just this part here. And according to what the question says, this portion here, this bowl, is going to be, let me show a bit more of the diagram. So this bowl here, right, is going to be making up, it's going to be generated through having this graph being revolved about the y-axis. So if you were to look at this graph represents one that is of an ellipse, correct? It is an ellipse. So if I were to look at this as an ellipse, it is going to be x square over 15 square plus y square over 10 square. This is equal to 1. So if I were to sketch this ellipse, I will be getting something that is like this. Here. And here, the center is at the origin. This is going to be minus 15. This will be minus 10. Here will be 15. And here will be 10. But if you were to look at this question, in order for me to get the bowl, we will just be basically using this part of the ellipse. Just this part. So we will be looking at this region here being revolved about the y-axis. Which means that we will take this equation, x squared blah blah blah, we will make x the subject so that we can revolve it about the y-axis. So we have x squared over 225. This is 1 minus y squared over 100. So x squared, this is equal to 225 of 1 minus y squared over 100. So x is supposed to be plus or minus of 15 square root of 1 minus y squared over 100. And for this plus minus 15, it actually talks about one part of the graph, which is this part, which takes all the positive x coordinate. So this entire part here is x is equal to positive 15 square root of 1 minus y squared over 100. And then this part here is x is equal to minus 15 square root of 1 minus y squared over 100. Okay? And in order for you to take a region and then try to rotate it about the y-axis, the volume that you will be expecting will be found by taking integration from minus 10 all the way until 0 of x squared, and I'm talking about this part of the graph. So we are talking about 15 square root of 1 minus y squared over 100 square dy. So this will give you the volume of the entire bowl, But this is not what the question asks for. The question is asking for the empty space. Empty space after all the water is being dispensed into the bowl. And according to the question, the water went all the way up to fill the entire cylinder, to fill the entire container. So, so the entire volume is going to be drained into the bowl. So I will need to take the volume of the bowl minus away the volume of the cylinder, which is going to be pi r 5/2 square times 20. Then minus away the volume of the cone, which is 1/3 pi 5/2 square times 4. So this is going to be the volume of the empty space that the question is talking about. And if I were to press this into the calculator to 3 decimal places, it is 4293.510 to 3 decimal places. Okay. If there were to be a chance, maybe we can, if there were to be a chance to do this kind of question again, I think we should try to have a little bit more discussion about this. But anyway, let's take a look at the last question, which is looks complicated but it is surprisingly easy. Like, it's really a very straightforward question to me. There is very little surprises in the last question. And it's actually pretty okay, as in like it won't take a lot of time to do this last question. So for this last question here, we have point M, which is 0.8, 0.6, and a 0. Then point N, which is 0.4, minus 0.9, and a 0. And there is this point T. According to the question, T is on this control tower that is vertically above the point O, and it is 70 meters above ground. All these units of measurement are in km. So if it is 70 units above ground, that means T must be like 0, 0, and for the Z direction, it will be 0.07. So these are the coordinates of the 3 points. And for the very first part, we are supposed to find D. And to prove that the coordinates of this point D, the errant drone is having a coordinate of this. And the clue that is given to us is that when a laser rangefinder is beamed from M and in the direction of 271, it's going to be directed at the drone. So we have something that is like this. So for part 1, so from M, it is going to be, okay, let me just write down. Okay, so for M, the coordinate is this 0.6 and a 0. And a laser is going to be pointing in the direction of 27 minus 1. And it's going to point at D. And then there's another point, another laser that's going to start from N. N is at 0.4 minus 0.9 and 0. And this is going to be also pointing at D, which means that the cross section of these two lines is going to be at D. And according to the question, this laser beam is going to pass through another point. The other point is at 0.8, 0.75, and a 0.3. You know what is the problem with this question? The problem with this question is the numbers that are given. So they are very boring numbers. So the calculation wise, right? I think in the exam, no one cares, okay? But I think when you are doing this as a practice, the numbers itself are just pretty, like it's really a bit too tedious, because it's just numbers. So anyway, in order for me to prove that D has this coordinate, I'm going to form the equation of the line that passes through M and D, and I'm going to form the equation of another line that passes through N and D, and I'll solve simultaneous equation, and if everything goes well, the coordinates of the intersection point will represent the coordinates of D. So for this line that passes through MD, it passes through this point, so 0.8, 0.6, and a 0, plus, let's go for lambda of the direction 2, 7, minus 1. As for this, I need a direction that is parallel to this. So if I were to just come up with a vector that is parallel to ND, I guess that can be 0.8, 0.75, 0.3, minus away 0.4, minus 0.90. So a direction that is going to be parallel to ND will be 0.4, then this is 1.65, this is 0.3. So for the line that passes through N and D, this will be R is equal to 0.4 minus 0.90 plus, let's go for mu of 0.4, 1.65, 0.3, which means that at the point D, the two lines are going to intersect. If I were to solve them simultaneously, R is the one that simultaneously happened. So I'm going to match the R to the R. So at the point D, 0.8, 0.60 plus lambda of 2, 7, minus 1. This is going to be equal to 0.4 minus 0.90 plus mu of 0.4, 1.65, and 0.3. And from the first row, we will get a 2 lambda, then minus 0.4 mu is equal to negative 0.4. This is my first equation. From the second row, I will get a 7 lambda minus 1.65 mu. This is minus 1.5. This is equation number 2. And for the last row, we have a lambda plus 0.3 mu. This is equal to 0. And if I were to press all this into my graphing calculator, solving this as a linear equation, we will get lambda to be equal to, lambda is equal to, from my calculator, minus 3 over 25, and mu is equal to 2 over 5. This should help us to solve for D if I were to substitute either lambda back into here or mu back into here. So from here, OD, let me use this. So OD should be 0.8, 0.60 plus lambda, which is minus 3 over 25 of 271, and so 27 minus 1. And if you were to just press your calculator for the numbers, this should be 0.56, negative 0.24, 0.12. So the coordinates of D will be 0.56, negative 0.24, 0.12. Yep, and this is what you're supposed to show for the coordinates of D. Very, very tedious, not because it is difficult, but because of all the decimal point. But I can understand why Hwa Chong did this last year. Because in one of the earlier years, there was one vectors question that came out in A-levels that has numbers that are also very, very tedious. Okay, it gave a lot of students a surprise, because when we are doing our exam, especially if it is a Cambridge exam, you will be expecting very nice numbers, right? But I think that that particular vectors question has numbers, I cannot exactly remember, okay, but he has numbers that are like 28 over 11, then 13 over 23, that kind of numbers. So it makes a lot of students feel very, very uncomfortable. They thought they were wrong, but actually it turns out to be pretty okay. Okay, next. Next, part 2. Part 2, I want to find the acute angle between the flight of the drone catcher and the horizontal ground. The drone catcher is going to be deployed from O. Then after that, you will go to D. So you'll go from O to, whoops, what happened? So you'll be going from O to D, which means that we are looking at something that is like this. Okay, this is the flat ground. So you will start from O and you will go directly towards D. And we are supposed to find the angle that is between this and the flat ground. I'm going to call it theta. In order for me to find theta, I'm going to make use of a vector that is perpendicular to the flat ground, which is pointing upwards. So a direction that is going to be parallel to this will be 0, 0, 1. And because it is 90 degrees, this angle here will be 90 degrees minus theta. And I'm going to use 0, 0, 1. And I'm going to use the fact that I know vector OD to find, to come up with an equation that involves 90 degrees minus theta. Then I will solve for theta. So I'll use dot product 0, 0, 1 dot OD, which is 0.56 minus 0.24, 0.12. This is equal to modulus of 0, 0, 1, modulus of 0.56, negative 0.24, 0.12. Then cosine of 90 degrees minus theta. And to make sure that I'm working on acute angles, I'm going to put an overall modulus. If you were to work out the numbers, you will get a cosine of 90 degrees minus theta. This is equal to 0.12 divided by this is square root of 1. This is going to be square root of 0.3856. That means theta is going to be 90 degrees minus cosine inverse of this 0.12 over square root of 0.3856. This will help you to find theta, and that is 11.1 degrees. So this is for part 2. Part 3. Part 3 is also very, very simple. Part 3, we are supposed to find the equation of the plane P. And plane P contains T, M, and N. T, M, and N, these 3 points here. So for these 3 points, let me do a quick sketch, okay? So for part 3, we are looking at the plane, or you can just see it as any plane, that contains 3 points. The points will be point T, point M, and the point N. So in order for me to find the equation of the plane, I'm going to go for Tm as a vector that is parallel to the plane. Then Tn, another vector that is also parallel to the plane. Crossing these 2 vectors should give me a direction that is perpendicular to the plane. So let me find vector Tm. Vector Tm is going to be OM 0.8, 0.60 minus away OT, which is 0, 0, 0.07. And this gives me a 0.8, 0.6, and minus 0.07. I will find Tn. Tn will be On. On is equal to 0.4. 0.4 negative 0.90 minus away OT, which is 0, 0, 0.07. So this will be 0.4 minus 0.9 and a negative 0.07. So the normal vector can be found by taking Tm cross Tn. Okay, if you were to cross these 2 vectors together, the result is going to be negative 0.105 and a 0.028 and a negative 0.96. And if you were to look at what you are supposed to prove, the numbers that are here sort of like synchronize to this, provided that you factorize out 0.01. Then I will have a minus 10.5 and a 2.8 and then a negative 96. So I'm going to make use of this as the normal vector. That means the plane P. It will be r dot minus 10.5, 2.8 and minus 96 is going to be equal to, I'm going to take the position of vector of the simplest possible coordinates. I guess it will be t. So 0, 0, 0.07, this dot minus 10.5, 2.8 minus 96. This should give you a negative 6.72, okay, which is what the question wants you to show. So this done, this done, this done. The last two parts are also very simple. They are basic questions because now we have this point G, which is the jammer gun, and the jammer gun is supposed to be at the foot of the perpendicular from the drone to the plane. So if the drone, which is at D, and its coordinate is 0.56, negative 0.24, 0.12 to the plane, and this plane is r dot minus 10.5, 2.8 and minus 96. This is negative 6.72. So G will be here. This will be point G. This. Okay. So to find the foot of the perpendicular, I'm going to make use of the process that I discussed on the topic outline on Achevas TV, and it is probably the same as what you guys are doing in your schools also. So I'm going to first form the equation of a line that passes through G and D. So let's say LGD. This is R is equal to, since it passes through this point, 0.56, negative 0.24, 0.12. Then plus, let me go for gamma. Gamma of a direction. The direction of GD is going to be negative 10.5, 2.8 and minus 96, correct? Because this is the normal vector, so the normal vector should be parallel to GD. So this minus 10.5, 2.8 and minus 96. And since the line that passes through GD will be intersecting P, I'm going to once again solve this as a pair of simultaneous equation. Looking at this as if it is equation number 1, looking at this as if it is equation number 2, I am going to sub equation number 2 into equation number 1. So it is going to be 0.56, 0.56 minus 10.5 gamma, negative 0.24 plus 2.8 gamma, 0.12 minus 96 gamma, this subbing into here, dot minus 10.5 minus 96, this is minus 6.72. If you were to expand the dot product, I'm going to just skip, okay, there are so many numbers here, so it's just this multiplied by this plus this multiplied by this plus this multiplied by this equal to this, making me like gamma the subject. Gamma will be equal to 0.001216.2. I'm just thinking about my Hwa Chong J2 students last year. Like, I wonder how they have suffered doing this vectors question, because the numbers is just, I mean, because the questions are so easy, so you really don't want to give up, you know, so you just want to persevere and continue, but the numbers are just getting longer and longer and longer. So anyway, gamma is this. So if I were to substitute back into here, I will be able to find OG, which will give us the coordinates of G. So OG is going to be equal to 0.56 minus 0.24, 0.12, and the gamma is now 0.001216.2. then minus 10.5, 2.8 minus 96. This will give me OG as 0.54723, negative 0.23659, and a 0.003246, and therefore I know the coordinates of G will be 0.547, negative 0.237, and a 0.00325. And hence, I want to find the distance GD. Actually, my hand is extremely painful. I don't know whether you can see. Okay, you cannot really see, but it is so painful doing this question. Goodness. Part 5, super easy. It is just going to be modulus of GD. So for GD, it is going to be taking OD, which we have, minus OG, which we just found, and this is 0.01277, negative 0.00341, and 0.116754. Usually I'm okay, but this question is like really very long. So GD will be square root of 0.01277 square plus minus 0.00341 square plus 0.116754 square, and this is 0.117. Oh, this is in km, so I must write this as 117 meters. Okay, but I although this is very tedious, right? But if this were to come in the A level, I think a lot of people will feel very happy because it is just writing a bit more, but you know you are definitely going to score. Okay, there's no twist at all in this question other than the fact that it is described based on a real life scenario. So okay, we have finally finished this. It took longer than I've expected to, not about thinking but about writing this question. So that's it for this Hwa Chong paper. We have finished the entire paper, and I think this